3D graphics. This is absolutely not a comprehensive presentation on how to do 3D graphics. There are lots and lots of YouTube videos out there. I'm even starting a series. What I want to do here is just hit on some concepts and some high-level concepts that will help you put your 3D graphics into your presentations. Let's jump right into it. Perspective versus orthographic projection. You will have at least two options for the projection style of your graphics. The first is perspective, and this tries to make it the most realistic, like what your eye would see. So we're looking at a cube. So even though the cube has equal dimensions on all sides, the farthest side looks the smallest and the closest side looks the biggest. And then for orthographic, well, now all the dimensions are the same. So in our eyes, this looks a little bit distorted. And as you stare at things like this, sometimes your eyes can do weird things like invert them or whatever. So it's not as accurately conveying or not as intuitively conveying dimensions. Here's the problem. It's very easy to just render things in perspective projection, and the individual graphics look awesome. And then as you put together a presentation, you'll put two of them together, and this is actually the same object, the same render, just placed twice. And something looks off and weird here. And that's because each is rendered with your eye in a certain location, and when you place them side by side, that's odd because now your eye has to be like in two locations or something. It does not look right. If you absolutely have to do this, render in orthographic, and then you can place anything in any kind of array, but it's still going to look distorted. What I think is best to do when you're going to show multiple 3D objects, and here I'm showing an array of 3 by 3, render them all at the same time. And that way in perspective mode, notice all of these look a little bit different because they're in different orientations. They don't all look the same like in orthographic. And so to our eyes, this is very intuitive what is going on. So when you're arraying multiple objects and in perspective mode, you really should not render them separately, render them together. If you absolutely must render them separately, I really think you should use orthographic projection instead of perspective. On to the next topic, volume versus surface shading. Well, before we can even talk about shading, we have to answer the question, what on earth is a shader? Well, suppose I want to create tree bark. Tree bark is very bumpy, very detailed. If I were to create a mesh that actually resolved all of those bumps and cracks and other things in tree bark, that would be a huge, huge mesh. And if you're making a game with, and you're really limited on memory, maybe the game's going to go on your watch or your phone. Well, you just can't do that. You have to use a coarse mesh. So the mesh is the shape of the object. The shader is what the surface of that object looks like. So we can create a very coarse mesh, and the simple shader, we just say, hey, that's some kind of brown. But we can get more complicated. And in the shader itself, we can make it look as if it's bumpy and craggly. But actually, it is just this mesh. Those bumps aren't actually there. Those are tricks that the shader is doing. And so there's this trade-off of what you do with your mesh and what you do with your shader. In general, you want to do as much as you can with your shader because your renders will be much, much quicker. The meshes, you want to minimize the number of faces that are on them. So that's what a shader is. It's what the thing looks like, not its shape. What does a shader look like? Well, in a program that can do shading, it generally looks like this. This is called node-based shading, and it's a kind of a flow of information and not something I want to get into here, but we'll definitely be doing in the class. If you want to shade an object, there is surface and volume shading. So surface shading, it's like it's made of paper. Now, we can use transparent paper or we can use opaque paper. Typically, the opaque is what is commonly done. If we're showing off some kind of electromagnetic thing and we want to peek inside somehow, then maybe we want to use some kind of transparency. But when the surface is transparent, it's really like it's made of plates of glass and it doesn't look like it's filled with a volume. So there comes volume shading. It doesn't at all color the surface. It fills the volume with like a fog. And there's all kinds of options. You can make these fog look like clouds and change their colors and do all kinds of other crazy things. But at its simplest, it's a cloud. And we can have a very low density cloud or a high density cloud. So this is what we would want if we want an object that kind of looks a little bit translucent. But if you notice looking at this, something still seems missing. This does not look completely like a translucent object. And in fact, the trick is to make something look like a translucent object, it involves both surface shading and volume shading. Neither one of those alone can make it look realistic, but if you combine them, you can get a nice translucent effect. Okay, so that's surface versus volume shading, and you can use them in combination. Here's just a bunch of miscellaneous tips that I've come across that I think for this high-level discussion we're having now are very appropriate. The first is matching your background color. Very often you will render something with a background color, and then in PowerPoint you can click and make that background color transparent, and then stick it on a background, and well, you got to be careful. So I'm going to render my cube, but with two different backgrounds, a ugly, bright RGB red and a ugly, bright RGB green that I would never actually use, but it's good for demonstration purposes here. I will use those as the background colors. So I create two of these sort of translucent objects, but with either a green or a red background. And notice, if you're looking through this, I can see a little bit of the green looking through the object here. And in the same place, looking through the object, I can see a little bit of the red. Well, what happens if I take this cube, bring it into PowerPoint, maybe I click on the red to make that transparent, and then stick it on a green background, or vice versa? Okay, so here's both of these cubes put onto a green background. So the object rendered with the green background, the green made transparent, and then put on yet another green background, this looks nice. I can see the green through it. However, if I took the object rendered with the red background, made the red transparent, and put it on a green background, this starts to look a little bit goofy because now when I'm looking through the object, I see red and not green. Now I can look at this the other way around. I stick those same two things on a red background. Well, the cube that was rendered with a green background looks goofy because I'm looking through it and I see green and not red. Whereas over here, now I'm looking through it and I see red. So if you're going to do things this way, you need to match your background color or things will look a little bit goofy. Here's another thing. In rendering engines, you can very easily make objects reflective and just turn up the metallic setting or sometimes a reflective setting, and there's other ways you can play with that. So if I go ahead and do that and I render it and render a sphere, by default, this is what I'm going to get. And you might wonder, why does that look so flat? Well, because if it's going to be all shiny, it's not going to look shiny unless there's something to reflect off of it. And so in Blender, you can set an image to your world setting. So it's like you wrap your object in this image, and now that light can reflect off of your object, and objects now look metallic and shiny. So there's so much of these kinds of things where you can make the material settings just what you want, but it still doesn't look like that material. For example, if you're making glass, it may not look like glass until you put something on the other side of it to sort of refract through the glass. Just like shiny metals don't look shiny unless you give them something outside to reflect off of them to make them look shiny. Conveying three-dimensional geometries. For three-dimensional geometries, I really like to add sort of motion, an orbit, a slow kind of orbit, definitely not fast because that can be distracting. And that's because your eyes can play games with you. So what do we do if we have an object? Here we have a cube, right? So if we show this rotating, well, we just see a rotating cube, right? But when this rotates, suddenly it becomes obvious we weren't really ever looking at a cube. We were looking at three surfaces that were, even those surfaces aren't part of a cube, they're distorted in some way. And this happens when you're looking at a static object, that your eyes can play games with it. And you're not necessarily interpreting what is meant to be conveyed in the slide. So for three-dimensional things, I love to have orbits, particularly orbiting and angling in more than just one direction. Here it's just spinning around its z-axis. If we can do a little bit more complicated rotations there, it'd be even more clear what that is. So when the geometry is really important and not obvious, always, 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 I incorporate some kind of orbit. Here's an example of what I've done. I teach a lot on finite difference time domain and another similar technique, finite difference frequency domain. And there's a concept in here, something called a Yee grid cell, where you're staggering the X, Y, and Z components of all of your fields, E, H, B, and D, in this weird sort of strange way. And it's very hard to draw in a flat kind of way. And even if you're looking at this in a three-dimensional static image, that's pretty good. But when I add an orbit like this, suddenly the 3D computer in a person's brain kicks in and they can just understand the three-dimensionality about that. So anyway, this is an example of how I've used this in my work. The last thing, and that's visualizing waves. This is, I guess, a little bit special to me because I do a lot of electromagnetic sort of things. And I love to have waves moving in my simulations because if it's just a static wave, which is what most people show, it's very hard to tell like which way things are going. If you can just animate the wave, a lot of times what it's doing becomes really obvious. So to me, I recognize this as an invisibility cloak, but to a person who didn't know anything about that, they would at least see that this wave is some kind of somehow wrapping around an object and coming out the other side relatively unaffected. But even more, I can make waves look reasonable with this white background. But I think waves look even more stunning when they're shown against a black background. So more and more, I'm adopting a black background when I need the graphics to be really snazzy. I'm trying to show off. With a black background, you could do all kinds of these little glow effects, which make things look scientific and technical and all that. But another thing I could pick on here is the three-dimensionality. I'd love to add some kind of orbit to this. Another thing I pick on is the flat black background is a little bit boring to me. And if this is going to be a slide that's up for a while, or maybe it's playing in a TV in a hallway or something like that, it's a little bit boring. Well, what can we do? Here's an example. So we added a very slow camera orbit. We don't want that to be too fast or it can make people dizzy. It can distract from the image. And we've added some stars in the background and some nebula, just enough to add some interest. And this becomes something that's really, really appealing and is relatively easy to do in a 3D graphic software like Blender. So I love doing things like this, and the three-dimensional computer in everybody's brain activates and they understand exactly what they're seeing here. Now, as you get into graphics, you might create these stars and nebula and you love them. And so you make them super bright and this looks awesome. And somebody would look at your presentation, wow, that is really awesome. And maybe not even see your cloak because the background is way too distracting. So even though you love it and you're proud of it, you really have to keep the attention focused on what you're presenting. So it is possible to go overboard with the graphics. So something like this, I think, would look a lot better where the stars and nebula, they're there, they add some interest, but they're suppressed. And now the attention comes on to the object that you're looking at. And some of the things we'll talk about later, there's actually some more advanced things going on here. I'll just point out one. Notice the blurring around the edges. And this has to do with your eyes being drawn to contrast. So if these fields just had a hard stop, your eyes would probably go to the corners first and miss it. But just by adding this little bit of a blur, it really sort of amplifies and draws attention first to this object in the middle, which I guess here I wanted to be the center of attention.